Hello and what's up guys? In the previous video I have talked about the commonly used commands and variables inside CMake. So I have introduced you to the documentation of CMake, and today I'm gonna begin by writing the CMakeList.txt files for our previously created executables, the publisher and the subscriber, if you remember. In this video, I will also talk about the Package.xml file, how to fill it, and I hope to wrap it up and finish my video series about the ROS2 package creation. So I advise you to watch this video to the end, and of course, do not forget to subscribe to my channel and to hit the notification button to stay updated. So let's start. Alright, so if you remember, we have previously created this overlay, this workspace for ROS2 package. And here, if I go to source, I have created two packages, the minimal publisher and the minimal subscriber. Let me begin by talking about the minimal publisher. Here we have put like the source codes for the lambda.cpp and other two executables. I just wrote the code for the lambda.cpp, and for the rest of executables, I didn't write their code because it will be like very similar. Now for the package list, CmakeList for the CMakeList.txt file, as I said before, this is very essential to specify the policies that are needed during the build process. What I did is that I have automatically generated this file was automatically generated because I have used, if you remember, the command in the terminal in order to create my package, which was ROS2 package create, and I have specified the build type to be CMake. And if you don't remember about this, please go ahead and watch my previous video right now in order to remember it. And actually, I have this CMakeList.txt file will be automatically populated. So I kept the automatically generated piece of code, and I have manipulated it a bit. I have changed some lines of code, and I have added some lines. So I have previously done all the work, and I just want to walk you through it in this video. So the CMake minimum required command will allow you to specify the version, the minimum version required of CMake during the build process. It was set to 3.5, and actually this was automatically generated by the system. And I will tell you about the line of codes that I have written myself, so don't worry about it. Now, why is the 3.5 version is good for me? Because if I go ahead and open my terminal, I can type CMake version, and I can see that my CMake version is a 3.10.2. And actually, you will have the same version if you installed ROS2 Eloquent just like me, as I have explained about the ROS2 installation in a previous video. So you can go ahead and watch my previous video about that if you don't remember. And actually, a 3.10 is a higher version than a 3.5, so I should be fine. Now here the project command will allow you to specify the name of your package, and here I have put this name myself. You can put any name you want, but please remember that this name should be the same one inside the Package.xml that I will talk about later on in this video. Now here also this code is automatically generated. It will specify the standard for the C language, and this is like how this will govern how to interpret the C language, everything written in C language inside your source code or anything else. So it was set to 99. Commonly, it will be set to 99, so we should be fine. Now, here you will set also the standard for the C++ language. And as you can see here, we are dealing with variables, and these are more specifically called the flags. And we are setting them to numbers. And actually, this is automatically generated, all of this. Now, also here, you will have the option to manipulate what will happen during the building process. You can you can turn on the warning. You can make the system throw exceptions in some cases. So you don't need to worry about this piece of code right here. You can keep it as it is. It is automatically generated. Now, of course, we need to we need to find our packages that are needed in order to build our executables. These are supposed to be our dependencies. So first, you need amend CMake. And actually, this package will add a lot of good functionalities into your building process. So I advise you to keep it, and it is useful. So, but if you remove it, I mean, you won't face any issues or any errors. But you can keep it; it will be a good thing. Now here, what I have written myself. Find package RCLCPP, because I have included this library inside my source code, if you remember, and also I have included the std messages, and I have put this this word required, because if the system somehow didn't find these packages, it will throw an exception and it will stop the building process, because these libraries are very essential for my work. I cannot do anything without them. Now I can proceed to building my executables using the add executable command. Here I have specified the name of the executable, publisher lambda, publisher member function, etc. And also I have specified the source file that is needed to build my executable, and of course it is written in C++, and I have written it previously. Now, in order to add the dependencies that are needed to build the executable using this source file, there are two ways essentially to add those dependencies. First, you can use the amend target dependencies command. Now, I want to let you know that you might see one or two new commands inside the CMake in this video. So don't worry about it, I will explain them. But mainly I have explained pretty much everything in my previous videos when I talked about the CMake documentation. So one of these new things is the amend target dependencies. And actually here you can specify the name of your target after adding it. It can be a certain executable or a certain library. And here you add the other libraries that are needed to build such an executable. So these are the dependencies. And as you can see, I didn't specify any any absolute path or anything. The system will know everything by just providing it with the name of the libraries, of course after finding these packages or these libraries using this command find package. Now the other way to do it, and I have talked about it in my previous video, is that you can use the target link libraries, and here you will put the name of your executable, let's say publisher lambda, and then followed by the dependencies or the packages that are needed to build such an executable. But of course, as I told you before, the system won't recognize the location of such libraries and their dependencies. So in order to help the system to find such stuff, I need to do some modifications and I need to add some code. So let me open my previously explained notes about CMake. All right. So if you remember, after using the command find package, some of the variables will be automatically populated, if you remember, and I will use them with the include directories and the link directories commands in order to add the paths for the library files and for the header files used by such libraries to the search pool of the system to help the system find these dependencies. So let me use first include directories. So I will use them actually before adding the executable. Include directories. And for the path of such directories, I will put the name of the library. And it will be followed by include dires as such. And the same thing actually will be repeated for the std messages. All right. And also I need to add like my library files using the link directories command. And here I will use the name of the library followed by libraries. So RCL CPP followed by libraries. And the same thing should be repeated actually using the std messages. All right. And then the system will automatically be able to locate the RCL CPP and the std messages. And of course, I should like remove the amend target dependencies. And this is like another way to build a certain executables against some of the needed packages or dependencies. But this way actually can cause you some problems. Sometimes the system won't be able to locate certain needed files and it will cause you an headache. So trust me, you don't want that. So this way of like building executables or libraries against some dependencies is less and less used nowadays. So my advice to you is to stick with this command because it will do everything on its own. You see, it took me less like words, less lines of code to implement it, and also it will not give issues like the target link libraries. So let me like delete those for now, and let me delete this one, and I will stick to amend target dependencies. Now the same thing is repeated for the other two executables, no big change. Now finally for the install command. Now the install command, I didn't talk about it earlier, but it's fairly simple. You put like the reserved word targets in uppercase as you notice, and here you put all of your targets, and in our case these are our executables. And then you put the reserved word destination followed by the destination where you want the executable or the binary files for such executable to be placed. So what I'm doing using this command is that the like generated binary files for my executables will be located in this directory right here. And actually this directory right here has an implicit like portion which we call a prefix for this path or directory. And the prefix is actually the path for your overlay. Now in this case it will be like home, desktop, ROS2 WS trial if you remember, and then followed by install. And this is actually, this directory was created by Culkin if you remember, the build tool, and then followed by your package name, and the package name actually is the name specified here by the command project. So this is implicitly included here. Okay, so I have specified library directory and then followed by the project name, because this is like needed in order to allow the ROS2 system to find your executables. When you run the command ROS2 run, you specify your package name and your executable. So this command won't be able to activate your executables unless these executables are placed in this specific path. Okay, there's no way around this. Okay, now of course you can do another thing if you don't like to use the install, and I have talked about this earlier. You have a certain variable that will specify like the location of the executables after creating them, and this is actually executable output path. And here you can use the set command in order to set this variable to any desired path that you need. In our case, you will need to put like the overlay the overlay path, followed by install, then the project name, and finally library and project name. You need to include the full absolute path. But of course, I think that the install command is more convenient, so I will stick to this one. And also, if you didn't use the install command, you will get a certain warning, but this won't cause any problem. Don't worry about it. If you decided let's say to use the executable output path option, this will give you a warning, but no errors will happen and the nodes will function properly and everything. But if you don't like warnings, you have like issues with them, I don't know, so you need to use the install command. Now of course here this is automatically generated by the system, and this is used for testing. You can remove it if you want. I will remove it right here. It's not needed at this level. You don't need to worry about it at this level. Now finally, I will conclude my code by using the amend package. If you remember, when I talked about find package command, I told you that the system won't be able to find certain types of packages. And actually, if you want your system to find this package that you have just created with its executables, you need to include inside the CMakeList.txt file of this package this command right here, amend package. Okay, so this will allow mainly your system to find such package using this command. And this is needed if you need this package, let's say, that you have just created in order to create other packages. So if you need it as a dependency, you need to include this line of code, this command. So this is a good practice. Now this is essentially the code for the publisher node, let's say, or executable. Now if I go ahead and open the CMakeList.txt file for the subscriber, it will be essentially the same. Like there is no difference except for like the executables. So their names might change, or the location of the source files that are needed to build such executables, but everything else is the same. And also I'm relying on the same libraries, as you can see, the RCLCPP and the standard messages. And also you can remove this piece of code for the testing, no need for it. And here we go. Now that's it essentially for the CMakeList.txt. Now let me go ahead and expand the Package.xml for the subscriber node. Here I have relied on the automatically generated code for the Package.xml, but you don't need to change anything except for the name of the package right here, which, as I said before, should be the same as the name that you have passed to the project command inside the CMakeList.txt file. As for the other stuff, like you can include the description, like what does your package do, your email, the license that is used, like Apache 2, for example. And also you can specify the dependencies that are used during the build process and the execution of your packages. But this is not necessary. As I said, this is the only thing that needs to be filled, the name. And in this way, you won't face any errors. But if you want to keep it professional, if you want to share your work, you need to fill in the rest of the information. Now, that's it. So now, after filling everything, now for the publisher, not the package.xml will be the same, but the name will be different, of course, for the package. Now, let me go ahead and run it for you, just as a proof that everything is okay. So first, let me go to this workspace and let me use Culkin. All right, so everything is fine. As usual, I will go here and I need to source everything. So I will source local setup.bash and I will use ROS2 run. Let me rename it here. Okay, copy paste. And the name was publisher lambda, if I remember. All right, everything is going well. As you can see, hello Robotogeddon followers, and this is the message that I have specified in my source code in a previous video. Let me open a new window and repeat the same thing. Let me source my packages, and here I will use the subscriber node, and everything is going well. Now let me finish everything by talking a bit about the Culkin build tool. Now you might see different build tools that are available for ROS, but like the Culkin build tool is meant to be a universal tool that can deal with different like build systems and different environments. So it's very flexible, so I advise you to stick to it and use it all the time to build your packages. Now, I think you should be proud of yourselves because now you are able to build your own ROS2 packages to do anything, any like a job that you need. It depends on your projects. So I think that you have achieved something right here. So you should be proud of yourselves. Now, I hope you like this video, guys, and this series of videos about the creation of a ROS2 package. But for now, I will bid you farewell, and I hope to see you later on.